Half a billion years ago, the oceans belonged to something monstrous. Long before sharks, before fish of any kind, before anything had crawled onto land, a creature was already ruling the seas. And it looked like nothing alive today. Meet the Anomalocaris, the planet's very first apex predators. Quite possibly the strangest hunters that have ever existed. To the tiny animals of the Cambrian, these things were leviathans. Stretching a meter or more from head to tail, an Anomalocarid towered over a world where most creatures were smaller than your finger. And yet, for all their dominance, they kept their true nature hidden from us for almost a century. The reason comes down to how they fell apart. An Anomalocarid's body was mostly soft, and soft bodies rot fast. When one died, the flesh vanished, and usually only the toughest pieces were left behind to fossilize. So the very first parts of these animals that scientists dug up were just fragments, with no body attached to make sense of them. The first fragment showed up in the year 1892. It was one of the hard, spiny appendages that hung from the front of the creature's head. On its own, curled and segmented, it looked uncannily like the body of a shrimp. So that's exactly what the scientist called it. He named the strange shrimp Anomalocaris, which literally means strange shrimp. Which, by the way, is where this video gets its name. Nearly 2 decades later, in 1911, a second piece turned up. This time, it was the mouth. And on its own, it was just as baffling as the appendage had been. Round and ringed. It was mistaken for a jellyfish. And given the name Peytoia, then a third fossil appeared. A flattened oval lump, which everyone assumed was a sea sponge. They called it Lagania. Later still, a scientist took another look and decided the Peytoia jellyfish was simply sitting on top of the Lagania sponge. 3 creatures, a shrimp, a jellyfish, a sponge, all cataloged separately, all completely wrong. The breakthrough came in the early 1980s. A researcher was carefully chipping the rock away from a specimen, and the picture that emerged changed everything. There, fused to a single head, were 2 shrimp appendages with the ringed Peytoia mouth sitting right between them. More specimens showed the same thing, and the truth finally clicked into place. These weren't 3 small animals at all. They were the scattered pieces of one enormous super predator. With the whole animal finally assembled, scientists could start reading its body like a manual for how it lived. Take Anomalocaris itself, the first of its kind to be named. Down each side of its body ran a row of about 11 flexible lobes, and a wide tail fan finished it off at the back. Each lobe overlapped the one behind it, so the whole row worked together like a single rippling fin. Those fins would have rolled in a smooth, wave-like motion down the length of its body. Back in the 90s, researchers actually built a life-sized working model to test it. It showed that this swimming style was remarkably stable and needed almost no brain power to keep steady. In other words, Anomalocaris could glide effortlessly through the water while its real weapon went hunting. Its head? And what a head it was! A few years ago, fossils of its eyes were finally found. Each compound eye packed more than 16,000 individual lenses. That gave it razor-sharp vision, far beyond anything else swimming in the Cambrian seas. In a world of nearly blind animals, Anomalocaris could see its prey coming from a distance. Sharp eyes, grasping spined arms, a circular, crushing mouth. Everything about it screams predator. And for a long time, people assumed it ate absolutely anything it could grab. But there was one animal that might have been tough enough to fight back: the trilobite. These armored arthropods crowded the Cambrian seafloor, wrapped in hard, mineralized shells. And there's real evidence the two crossed paths. Some fossil trilobites carry distinctive W-shaped bite marks and large fossilized droppings, probably from an Anomalocarid, are packed with broken trilobite shell. Still, not everyone is convinced. Some doubt a soft-bodied hunter could crack a fully armored trilobite at all. One idea is that it didn't crush them outright. Instead, it may have grabbed a trilobite and flexed hard, again and again, working the shell at its weak points until it finally split open, exposing the soft body inside. Whether or not they truly cracked trilobites, one thing is clear. Different Anomalocarid species hunted in wildly different ways. Anomalocaris itself was built to snatch prey straight off the seabed with its long, spiked arms. Maybe a few species could tackle the armored ones, but all of them could easily pick off the soft, bizarre animals of the Cambrian. Creatures like the spiny hallucigenia and the slug-like Wiwaxia. But here's where the story takes a sharp turn. Not every Anomalocarid was a flesh-tearing monster. Some were the gentlest giants in the sea. Take one called Anomalocaris. Instead of grasping claws, its front limbs were lined with long, fine spines. Together, those spines formed a kind of living net. It would have swept that net through the water, straining out plankton and tiny drifting organisms to swallow. In other words, it fed exactly like a modern baleen whale, 500 million years before whales existed. It's astonishing to think filter feeding had already been invented this early in the history of animals. And here's the strangest part. A filter-feeding Anomalocarid was dreamed up before anyone ever found one. In a 2013 book called All Yesterdays, artists imagined how prehistoric animals might have behaved in ways fossils rarely show. One of their speculative sketches was a filter-feeding Anomalocarid, a creature that at the time simply did not exist in the fossil record. Then, just 1 year later, the study describing Anomalocaris as a real filter feeder was published. The artist had been right. So we know what these creatures looked like and how they ate. But what actually were they to answer that? We have to climb the tree of life, starting from the smallest branches. Anomalocaris itself anchors a family called the Anomalocarididae, which sits inside the broader group Anomalocarida, and inside Anomalocarida sit several branches, each holding its own cast of strange characters. The main ones are the Amplectoboluids and the Themisiocaridids and the Herdiids, plus the Anomalocaridids themselves. First, the Amplectoboluids, home to species like Amplectobolua and Lyrarapax that were both unearthed in China. One species of Amplectobelua even shows up in the Canadian Burgess Shale. And like Anomalocaris, it seems to have been a grabber, seizing prey with its appendages. Next come the Themisiocaridids, the filter feeders, the group our friend Themisiocarius belongs to. Their signature is those long appendage spines, fringed with even smaller spines, perfect for sieving the water. Fittingly, the name Themisiocarius itself nods back to that All Yesterdays sketch that predicted it. Then there are the Herdiids, the most varied branch of the whole family. One of them is Peytoia, which, yes, turns out to be an Anomalocarid after all. The very same name once pinned on that imaginary jellyfish from the tangle of misidentified fossils. And it too may have been a filter feeder, with long appendage spines much like those of Themisiocarius. The Herdiids also include a German species called Schinderhannes, and this one rewrote the timeline. Until it was found, everyone believed Anomalocarids had vanished with the Cambrian. But Schinderhannes lived in the early Devonian, around 100 million years after its supposed extinction. And finally, the namesake of the group, Herdia. It stood out from its relatives thanks to a large, hollow shell jutting forward from its head. Nobody is quite sure what it was for. It was hollow, so it probably wasn't armor. One guess is that Herdia used it to stir up the seafloor, flushing out hidden prey to be trapped and eaten. So that's the Anomalocarids, branch by branch. But where does this whole family hang on the tree of life? They belong to a group called Radiodonta, which also includes another oddball, the five-eyed Opabinia. Radiodonta in turn sit within the Dinocaridids, a name that translates to terror shrimp, partly for their vaguely crustacean look, even though they were no crustaceans at all, and partly because, to everything else alive back then, They really were the stuff of nightmares. Zoom out one more level, and you reach the panarthropods, a vast assembly that gathers all the arthropods, plus the velvet worms and the tardigrades, those famous water bears. This is about as far back as we need to climb, because being panarthropods places the Anomalocarids right beside the earliest ancestors of all arthropods. So, in the simplest terms, the Anomalocaris were stem arthropods, a primitive offshoot that shared a distant ancestor with every crab, insect, and spider that followed. They carried just enough arthropod traits to belong on that branch, but enough oddities to stand apart from it. And, as Schinderhannes proved, they were no Cambrian flash in the pan. They survived the mass extinction that closed the Cambrian and pushed on into later ages, into the Ordovician, and even as far as the Devonian, as their fossils quietly attest. For a lineage that began as nature's first great predator, that is a staggering run of success. So here's the thing that really stays with me about the Anomalocaris. For 100 years, we literally held the pieces of this animal in our hands and had no idea what we were looking at. A shrimp, a jellyfish, a sponge. 3 dead ends that were secretly one of the first great predators on Earth. So it makes you wonder, how many other creatures are sitting in museum drawers right now, broken into pieces, still waiting to be understood? I'd love to hear your thoughts, so drop them in the comments below. And if you enjoyed this video, a like and a subscribe would really mean a lot. Thank you so much for watching, and I'll see you in the next one.